Okay. So the next topic, and it goes right along with what we've already been discussing, and that is vertex form of a quadratic function. So we want to answer the question, how is this vertex form similar to absolute value vertex form? So we're going to be making some connections to absolute value vertex form and quadratic vertex form. And you'll see, as we answer this question, you'll see that it's done the same way. Okay? Vertex form of a quadratic function looks like this. F of x equals negative a times x minus h squared plus k. Now, the only little part that I left out that might be included in some situations, which we're never going to see, is sometimes we put an a in front of this x also. That just means sometimes we multiply the x value by some number. We're not going to be doing that here. We're only going to see just x. Alright? As much as I can help it. Now, let's talk about the parts of this formula compared to absolute value. So absolute value, I'm just going to write it up here. The absolute value was this. Negative a, absolute value, x minus h, close absolute value, plus k. Now tell me what's different.
Parentheses and not the absolute value.
Exactly. It's the same, except two different types of functions. This absolute value function just had absolute value symbols. The quadratic function has parentheses squared because it's a quadratic. That's the only thing different. Everything else is the same. We determined the vertex the same way. We use the a value as the slope in a similar way. We use the k value the same way, and everything's the same. So, again, the vertex is h comma k. The value h is the axis of symmetry. And negative a determines the width and direction of the parabola. So if it's negative, it's going to be facing down. If it's positive, it's going to be facing up. Now, why use this form? I'm going to go ahead and tell you a quick answer. Because it's simpler. That's why. Because it lets us graph this function more quickly. The vertex form shows shows the shift on a quadratic equation in respect to its parent function f of x equals x squared. Let me make that more specific, more general than just shift. Let me mark out shift and put transformations. A shift is just one type of transformation. So, vertex form shows the transformations on a quadratic equation. It should be with respect to its parent function, f of x equals x squared. Now, let's talk about the transformations here. Everything relates back to the parent, correct? So all of these are relating back to the parent function. So if I add 9 to the parent function, what is this doing? What does the plus 9 tell you to do? If the k value is plus 9, what is that doing? Nope. We're not doing it with the x. We're doing it to the full function. So if I add a number to a function, what does it cause it to do? Up or down? Makes it go up if it's positive. So this is going to go up 9. Alright, Josie? What would this one make you do? If it's a minus 2? Down 2.
What about the one with the parentheses?
Alright, well, what does this minus tell you? Reflect. What does the plus 5 tell you? Go which direction? Left. Remember, you go opposite direction, right?
So these are just like the stuff we
Just like the stuff we did with absolute value. Okay?
Okay, so that'd be -1 times x, and then make it -5. Then -5 squared wouldn't make it positive 25, so wouldn't that make it go right?
I think you're asking the right question, but I don't know if I'm going to answer it the right way that you need to be answered. That it needs to be answered.
Okay.
Hold on just a second. Got it. So, number 4, let's do number 4. So, in number 4, which direction are we moving with the -4? Good. Right 4, down 1. Okay, and number 5, what are we doing? Vertical shrink by 1/3, and then what? Up 2. And then 6, Bo, what would this negative do? Alright, and then what? Yep, left 4. Very good. Alright, in this last problem we've got these shifts given to us. They're telling us what they are, and we have to write the equation. Mason graphed the parent function of a quadratic equation. Then he reflected the parabola over the x-axis. So we got a reflection. And translated it 7 units up and 3 units to the right. What is the equation of the new parabola? So, f of x equals, it is a reflection, so what does that mean? Negative. There is no stretch, so parentheses, x minus 3 squared plus 7. And that's it. Alright?
We pretty much already learned this.
Yeah, we've already learned this, just with a different function. That's why I said this is just continuation of what we've done. So let's do one of these problems real quick. Alright, so in number 8, what we're doing here, first of all, we can immediately determine our vertex. So the vertex is going to be what? 2, 3. Alright, so our vertex is 2, 3. Once we have our vertex, technically, I don't need a table because I can use the a value like a slope. It's going to hold true for just those two values, the next two values. Now, what is the a value here? It's 1. So I'm going to graph this point 2, 3. Go to the right, 2, up 3. And then I'm going to use my a value, use a as a slope. So, up 1, right 1. But, my reflected point would be up 1, left 1. So, draw that as a curve, and that's all you need. I don't need the table. All I need is 3 points. Basically, we're making a sketch. But if I've got those 3 points, that's good enough for me. Alright, let's look at the next one. So, what is my vertex in this problem? 0, comma what? -4. So, you can write it in if you want, but we're really not going to need the table. 0, -4. And then my a value is 1. So, up 1, right 1. And then up 1, left 1. And there it is. That's my sketch. It doesn't have to be perfect. Alright, I'm going to stop the video here.